Hey everybody, welcome to the absolute value test review. In this video I'm going to go over transformations of absolute value functions, evaluating absolute value functions, solving absolute value functions, and solving absolute value inequalities. You'll notice that the paper is split into two halves. I'm going to do everything on the left side, and then everything on the right side I want you to do, and at the end of the video I'll post the answers, but I won't work it out or explain anything. And if the answer is real easy, I might just post a hint. Okay, so that being said, let's get started. I'm going to translate the following graph, left 4, and reflect it across the x-axis. Plot 5 points and write the new function below. Okay, so I have f of x equals x, absolute value of x minus 4. If you want something to go right 4, you are going to, left 4, you are going to need to add 4 to the inside of the function. Alright, and if you want something to reflect, put a negative on the outside and that'll reflect it over the x. A negative on the inside, meaning inside the absolute value bars, that would go over the y-axis. So this is basically my answer. So I'll put a g of x to let it know that it's the transform function. And negative 4 plus 4, well, you can simplify that. We can just write g of x equals the absolute value of negative absolute value of x. I guess that's how you read it, or absolute value of negative x. Okay, so graph this. Well, if you want to graph this using the graphing calculator, just plug this in, hit Control T, and get some table values. But look at this graph. You see how it's going up 1 over 1, up 1 over 1, up 1 over 1. It's passing through every corner. So it's really easy to graph, actually. You're going to go left 4, so there it is, left 4, the vertex, and then it's reflecting over the x, so it's just going to open down. So if I want 5 points, I'll just do it like that. I can do more because it's so easy, but that's really all I'm looking for. And there's the graph of g of x. Okay, so that one's done. Let's move on to the next two. There's 2 here. You can plug in the other 2 there. You're evaluating for when a is 3, b is negative 2, and c is negative 1. All you got to do is just plug it in. So plugging in negative 2 for b and 3 for a here gets me this. And then you can pretty much type this into the calculator, but hey, since I'm teaching you this, the outside would be 4. The inside of the absolute value would be 0. So 4 times the absolute value of 0 is just 0. But really all I'm looking for is show me this top part and show me the bottom part that I circled. Okay? So looking at the next one, plug in negative 1 for C, 3 for A, and negative 2 for B. Okay, so there's everything plugged in. This will be negative 1 times the absolute value of 1 minus 2. Negative 1 times the absolute value of 1 is negative 1 minus 2 equals negative 3. So here's my final answer. And again, I'm looking for the setup and the final answer. And if you show me the in-between steps, that'd make me happy because that shows you did it by hand. But I don't blame you if you're going to use a calculator on this one. So describe these transformations. In other words, how do these differ from the parent function f of x equals the absolute value of x? So the absolute value of x is just one letter. So identify how many different things there are. So there's a 2, a negative, a plus 3, and a 7. So in other words, I have 4 answers here. What is this 2 going to do? This 2 is going to vertically stretch. So I'll put VS for vertical stretch. Okay, what's this negative going to do? That negative is going to reflect on the y-axis since it's on the inside. If that negative were on the outside, like with the 2, it would be reflect over the x-axis. This plus 3 means it's going to go left 3, not right 3, it's going to go left 3. Remember, it goes opposite of what you might think. And then what's this plus 7 on the outside? If it's on the outside, it's normal. So plus 7 would go up 7. If it's still minus 7, it would go down 7. But there we go. This next one, I have 1, 2, 3 things different. So what is the 7 over 4 going to do? Is it going to vertically stretch or compress? 7's bigger than 4, so I know if, without even using the calculator, that I'm multiplying by a number greater than 1. If it was a number smaller than 4, like 3, 2, or 1, then I'd be vertically compressing, but because it's bigger, it's going to vertically stretch again. And then this plus 8, or plus 1.8, excuse me, is going left 1.8. And then what's this minus 8.4 doing? That's going down 8.4. So that's it. Okay, let's keep moving on. This next batch of problems, I'm going to solve these. And then it's important to check for extraneous solutions. It doesn't happen often, but it does happen. Now, remember, you're going to solve for both positive and negative solutions. But you want to wait for that until you clear up all the stuff on the outside of the absolute value first. In other words, I'm not going to make my two equations yet until I plus 3 to the other side. And then I have negative 2 on the outside. 4y plus 7 equals negative 30. And now I need to divide out the negative 2. So now I've simplified it. You want to get it down to just the absolute value bars. Whatever's inside equals something. So 4y plus 7 equals 15. Okay, now you're ready to make your two equations. So equation number 1, 4y plus 7 equals 15. And equation number 2 is going to be 4y plus 7. Don't change anything on the inside of the absolute value, but just set it equal to negative 15 this time. Alright, so let's solve this. I'm going to minus 7 over, and so I get 4y equals 15 minus 7 is 8. And so I know 8 divided by 4 is 2. So that's the first answer. And then the second answer is minus 7 to the other side. You get 4y equals negative 15 minus 7 is negative 22. So I'm going to divide by 4. And you get y equals negative, this is 11 over 2. Or you can say negative 5.5 if you want the decimal answer. So these are my two answers. Now let's check the graph to make sure you did it correctly, because I do say in the instructions to check your solutions by graphing. So over here, I'll pull up the graph. So here you can see that I change the letter y to x because you can't graph any other letter other than x, and then you graph the left side of the equation. I plugged in the original, negative 2 times 4x plus 7 minus 3, and then I wrote equals negative 33. I put that in another line, and then you just do menu, analyze, intersection. Look for my Ti-Nspire videos on a more detailed approach to that. But you see they intersect at 2 and negative 5.5 for the x values, and both times they do output negative 33 for the y. So we did do it correctly. There are no extraneous solutions. Let's take a look at the next one. R minus 7 equals 2 times R plus 8. Now, can you divide out this 2? It's not really going to simplify anything now, is it? So you're better off not dividing out the 2. Whereas before, you wanted to divide out this negative 2 because, look, it's just equaling another number at the end. So when you have it two absolute value problems equal to each other, generally speaking, you probably won't have to divide out that 2 or divide out the number in front. So I'm just going to say r minus 7 equals 2, and then I'll treat it as parentheses, r plus 8. And for the second equation, I'll say r minus 7 equals, and you got to make one side negative, so I'll do a negative 2 times r plus 8. Okay, so let's solve this first one. So I have r minus 7 equals, distributing the 2 gets me 2r plus 16. And now I just need to cancel something on each side. So if I minus r over here, that's canceling one thing on the left side. And then I need to cancel something on the right side, so I'll minus 16 here and there. And this gets me negative 23 equals r. So there we go, we got one answer. Let's move on to the next one. So I distribute a negative 2. So I get r minus 7 equals negative 2r minus 16. So let's see here, I can add 2r. That cancels something on the right side. And then I can add 7 to cancel something on the left side. And so you get 3r equals negative 9. So now, how do you get rid of the 3? Dividing it. So you get r equals negative 3. So I have my two answers now, negative 23 and negative 3. So let's look at the graph. You can see that they intersect at negative 23 and negative 3. Again, I plugged in one side, so I plugged in x minus 7 instead of r minus 7 into one line. And then I did 2 times absolute value of x plus 8 into another line. And I menu analyze intersection, and I got negative 23 and negative 3. So no extraneous solutions, and I did it correctly. Yay, go me. Now let's solve these inequalities. Similar approach. Clean up all the stuff on the outside first. This negative 5 you might want to say, oh, it's going to be no solution because it's less than a negative. And my answer to that is not yet. Clean up all the stuff on the outside first. So 3 times the absolute value of 2a plus 8 is going to be less than or equal to 6. See, now it's a positive number. And then just get rid of that 3 in front. So you have absolute value of 2a plus 8 is less than or equal to 2. Once you get it down to the absolute value is less than, greater than, whatever, a number, now make your two-sided equation. Rather than create two equations, let's make a two-sided equation here. So I'm going to say negative 2 less than or equal to 2a plus 8 less than or equal to 2. So there's my two-sided equation. Take whatever is over on the right side, throw it on the left, just make it negative. Now, I can minus 8 to each end, and I'm going to get negative 10 less than or equal to 2a less than or equal to negative 6. And so I can divide by 2. Remember, if you divide by a negative number, you'd flip the inequality signs, but this is dividing by a positive number, so the inequality signs stay the same. But I get a final answer here of negative 5 is less than or equal to a, which is less than or equal to negative 3. And you draw your number line graph. So let's see, that's the final answer, so I'll circle that. So I'll move the paper over here. And you have your number line graph. Is it an open circle or solid circle? They're solid circles because the symbol is underlined. So you have negative 5, negative 3. Since the symbols were pointing to the left, you shade in the middle. Okay, and that's the other part of the answer. You want to make sure you graph these when you have the inequality ones. Let's look at the Ti-Nspire graph right now. So here the graph is showing you that it does intersect at negative 3 and negative 5. And the shading part, it doesn't really help you figure out whether you shade in the middle or shade on the edges. But the shading part is relevant for, what numbers could you plug in, I guess. Yeah, that being said, at least we got the intersection part correct. And I am confident that I got this part right, the shading part right. But I don't know of any way of using the calculator to determine whether you should shade in the middle or shade on the outer edges. That being said, let's just keep things moving to this last one. Okay, you got to clean up the outside stuff first. This one's a special one right here. So pay close attention. I'll explain it the best I can. When you do 4 minus 4, it's greater than 0. So when you divide out 5, it's still going to be greater than 0. So you have the absolute value of negative p plus 2 is greater than 0. So before I go any further, I want to look at the graph. The reason why I wanted to look at the graph before going any further is you see the bottom is a dashed line, and they do intersect at 2. But remember, if you have something on the dashed line, you can't equal that value. You can do anything else other than that. And you see how it's shaded all the way above. So it's saying you can do any number you want except for the number 2. That's what this graph is saying. So let me explain it to you like this. If you were to make this a two-sided equation, it would look kind of weird from this step right here. So it would say negative p is greater than 0. It's also less than negative 0. You can't have a negative 0. It's the same thing as 0. So it'd look like this, minus 2 to each side, and then you get negative 2 greater than negative p greater than negative 2. So therefore p, you flip all the signs, include the inequality signs. So it's saying p is less than 2 and greater than 2. That doesn't really make sense. So let me explain it to you like this. What is the number that you can plug in here to make this go to 0? I can plug in a 2. Negative 2 plus 2 makes 0. So I'm going to write it over here. I'm going to put negative p plus 2 equals 0. Okay? I'm not making a two-sided equation. I'm just doing it like this. So I'm saying negative p equals negative 2. So positive p equals positive 2. Alright? So what this is saying is p cannot equal 2. And you're like, what? Why? P can't equal 2 because it lands on that dashed line. So if it lands on the dashed line, it can't equal it. It can't touch it. If this were less than or equal to, if this were underlined, p could equal 2. But p can't equal 2 because it's not underlined. So plugging in 2 would make this go to 0. So you'd get a statement that says 0 is greater than 0. So with all this in mind, I'm just going to scratch that out. Let's write our answer. So basically, your answer is all real numbers except p can't equal 2. That's basically what your answer is, okay, right there. Now, how would you write this in interval form? Inequality form. It would look like this. It would be an OR problem. And so it would be negative infinity to 2 or 2 to positive infinity. So that tells me you can never equal 2. So that's a long-winded explanation of saying all real numbers, but you can't equal 2. So when it's greater than or less than 0, you got to keep an eye out for that. Well, I guess if it's greater than 0, it would be an equation like this. But if it were less than 0, then it would be a no solution one. Because if you can't touch 0, well then that's just all the negative numbers, and you get no solution from that. Excuse me. So, pause this right now. Work through the right side. I will give you answers or hints, and then check your work. Okay, so here are the answers going in reverse order. I got negative 15 and 12 for that last one. And then this one is an OR function. The inequality sign is going to flip because at some point you're going to divide by negative 2, which makes the inequality sign go to the right, which means you'll end up with an OR statement and shading on the opposite ends. This one, you just have one answer. When you do it both sides, you get the same answer twice, so it's negative 4 over 3. And then this one has an extraneous solution. I'm not telling you what it is, but I am telling you you will get an extraneous solution, and then you'll get g equals 1 for the real solution. These were kind of easy, so rather than tell you the answers, I just give you hints. I'm looking for 4 answers on the top one and 3 answers on the bottom one. These two, 0 and 43. And then this one, again, kind of easy, so I drew the graph, and then I left the function up for you to write. But if you could do this one, then you can do that one. And that's it for the video. Thanks for watching, everybody. Good luck on your test. Goodbye.